So now we're in a position to start thinking about reflection and perform a basic investigation. So I might ask a question, well, what's special about the angle of reflection? We can measure, and we'll mention it in the last little video, we can measure we can see in the first instance a reflected beam of light. So it starts off in a lovely line going across the paper, but then we've reflected it back towards the source, but we've got control over where we can reflect it back. Now I've got a little mirror on a block of wood here, which just makes it easier for me, but when you do it, you simply have to use a piece of blue tack and put it behind the mirror. So what you can do is, just like that, position the mirror. So I'll just use my block, there it goes, turn the lights back down, and there's our reflected light ray. So as our first investigation, we could say, well, first of all, let's record what's actually happening. And we know how to do that. We can use pencil marks to tell us where the light ray bounced onto the mirror and reflected from. Now let's give it its proper name. The light ray that strikes the mirror from the source is given a special name. It's called the incident light ray. We'll write that down shortly. The incident light ray. And the light ray which reflects from the mirror, that's called the reflected light ray. So incident, reflected. So let's just make a mark. So we've got a plain piece of paper underneath here. There's the pencil point going in, so there's my first mark. If we hold the mirror still and draw a line along the mirror, and then show where the light ray struck and where the reflected light ray came off the mirror. So you'll see when I turn the lights back on what's happened. The light ray, there's my two marks there, the light ray direction against the mirror, we simply draw that line in, move the mirror out of the way, that's where the mirror was, and this is the reflected light ray. So let's complete the diagram. And there it is. Remember, we'll call this one the incident light ray, and this one is the reflected light ray. And often in these diagrams we add arrows to show where the light ray started at the source and where it's reflected off the mirror, in this case off into the distance. So there's our mirror. How do you know that's a mirror? Well, there's another little bit of sort of symbolism used for that. These little crosshatch lines like that across the back of the mirror show where the back is. So this must be the shiny surface of the mirror. So this is our mirror. And this would be called a ray diagram. I suppose we should write light ray diagram. A ray diagram. So now that we've recorded it, which is a fabulous thing, a scientific thing to do, we can say, well, what can we learn from it? And let's just give a little clue about this. Would this little gadget, used in mathematics normally, but used in science as well, could this help? And of course that is a protractor, and that allows us to measure an angle in degrees. And there we are. Have a think about that. Which angles could we measure and what have we found out?